Hello everyone, I'm Vishnupriya from VIT Chennai. The topic I've chosen today for video lecturing is TLS or SSL communication. TLS stands for Transport Layer Security and SSL stands for Secure Socket Layer. SSL is the base protocol and the revised or better version of SSL is TLS. TLS is the one which is widely used now and SSL is not used anymore, and both are cryptographic protocols which ensure safe communication between the client and the server with the help of a digital certificate. So before going into TLS or SSL certificate, we need to understand about a few things. It is one of the familiar topics to us, which is HTTP protocol. What does HTTP protocol do? It ensures communication between a client and the server. So once you go to a browser and type HTTP slash google.com or facebook.com, the browser tries to make a TCP connection with the server. Before that, it understands the DNS, the domain name. With that, it goes to the server of the Google and tries to make a TCP connection. From there, the browser sends a HTTP request, which will be like get/index.com, and it is sent to the server side, and the server responds with the web page. So that's how a HTTP protocol works. When you're logging into Instagram or Facebook, let's see how it works. Okay. So you type your ID and password and you enter, right? So ID and password is compressed. The ID and the password is compressed into JSON data, and then it is then converted into mission readable data, okay, which is zeros and ones. Zeros and ones are the data which will be understood by the machine. So it is then converted into binary, which is zeros and ones. From here, it goes to the router, and then from the router, it goes to the server. So, for example, let's take the client and the router are connected through a transmission medium called radio waves. So there are various transmission medium. It includes electrical signals, light signals, infrared signals, and radio waves. So we are taking a radio wave transmission medium between the client and the router. So transmission is taking place, and from there it goes to the server. But there is a problem in this network. It is not secured. The JSON data is converted into binary, and binary is sent to the router. But there is a hacker here. When he wants to understand or decode your confidential data, the ID and password shouldn't be shared to others, right? But if there is some need for the hacker to get your data, he can easily get it. There are various detectors available. So with the help of the detector, when the hacker is present in the same room where the client is entering the ID and the password, he can use the detector and detect the radio waves, and can easily convert the radio waves into binary data. From there, the binary data is converted into the actual plain text. Okay, here is the hacker, and he can intrude into your network. Okay, this shouldn't happen. So to overcome this problem, we have something called encryption. Okay, there is a key being used here. So it works on the basis of symmetric encryption and decryption. With this data, a key is being used. A key is used to encrypt the actual plain text, and the encrypted data is sent over the network to the server side via a router. So a key is sent with plain text. So this can be accessed it can be accessible to the outside world. So again, in this case also, the hacker can easily decode the plain text and the key, because he has both the plain text and the key. Anyway, it reaches to the server, but it also reaches to the hacker, which shouldn't happen. Again, to overcome this, we have another thing called asymmetric encryption and decryption. So in asymmetric encryption and decryption, in the server side, both public and private key are present. The private key is present and the public key is also present in the server side. So we need to note something here. The private key it resides only in the server side and it is not shared to the outside world, but public key is made public. Okay, so in asymmetric encryption and decryption, see, the situation will be client tells the server that I would like to send some data or share a data and make a connection. The client tells the server that he wants to make a connection or send data. This is the first step. Then the client replies. A public key is sent over the network to the client side. With the help of the public key, this is the second step which happens. In the client side, a key is generated which is a random secret key which is called session key. Let me give a glimpse on what we are going to do now. The session key is going to be safely sent, encrypted and sent over the network so that it will be available both in the server side and in the client side. So we'll see how it works. Okay, here a session key is present. Let's take the session key is this one. What's the first step? The client tells the server that I would like to make a connection or send data. So the server responds by sending its public key to the server. So with the help of the public key, the session key is encrypted. The session key is encrypted and again it is sent over the network to the server side, and again the server uses its private key. The server uses its private key. Since we have used public key for encryption, we should only use private key for decryption. Okay, so once it is sent, the private key of the server is used to decrypt the data, the key. Again, what happens? The encrypted session key travels over the network and comes to the server side, and the encrypted session key with the help of, it was encrypted with the help of public key. This can be decrypted with the help of private key now. Since we follow asymmetric encryption and decryption, only private key can be used to decrypt this encrypted session key. I hope you understood. The client tells the server that I want to make a connection. Hey, I want to send a data is being transferred from client side and the server side. The client replies with the public key. Session key is encrypted with the help of public key. Again, the encrypted session key is sent over the network to the server side, and from there the encrypted session key can be decrypted with the help of private key. Okay, so now in both the sides session key is present. Okay, here the session key is present. Again, here also the session key is present. So from the session key, the plain text can be encrypted and sent over the network. It reaches the server side. Again, it can be decrypted with the help of the session key. Okay, which is on both the sides we are trying to have the common key, but it is being encrypted and sent over the network. So both the sides have session key only. Okay, nothing else. Again, you may think this one is a safe communication, but again, this is where the problem occurs. The man in the middle problem occurs here. Okay, here is the hacker and he intercepts into the network and pretends to be the server. So the client thinks that he is the actual server, and the client keeps sending data, sending the encrypted session key. Let's see what happens here. Okay, now you think hacker is the server, but he has actually intercepted and pretends to be the server. Okay, the client tells the server, hey, I want to send a data. This is being sent here, but the hacker pretends to be the server, intercepts into the network. Why does this happen? Because the network is unsafe. That's why this happens. Okay, so this one which has to go to this place comes to this place. Okay, remove this. This is not present. He pretends to be the server. So client thinks that he is the actual server, but he is the hacker. Okay, and he has his own public key and private key. The public key, this one is the public key of the hacker, and this one is the public key of the this one is the private key of the hacker. So once the client tells the hacker, hey, I want to send data, he sends his public key to the client. The client encrypts the session key with the help of public key sent by the hacker, thinking that it was sent by the server, and this encrypted session key is sent to again to the hacker, and with the help of the private key he can decrypt the encrypted session key. Okay, the same thing happens between the client and the hacker, but the client never knows that this one is a hacker, that he is communicating or sending data to the hacker. Okay, so again, to overcome this problem, we have another thing called SSL or TLS protocol. Here is our main thing, our topic for today. So we need to understand the things which we were talking before, because we need to understand why do we actually need TLS or SSL communication. To overcome all these problems, we have TLS or SSL communication. The protocol is a cryptographic protocol which ensures the safe communication between the client and the server with the help of digital certificate. There is a digital certificate present which is generated by CA. CA are the certificate authority. There are around 12 certificate authorities present. So when there is a need to have a communication between the client and the server, when there is a need to send data between the client and the server, the this thing usually happens. Okay, first step, the client tells the server that I want to send data. I want to send data. Send data. What does this server do? He goes and tells the certificate authority that I want to make a safe communication, and the server sends its public key to the certificate authority. So the certificate authority, we'll remove this for now. The server goes to the certificate authority. Certificate authority is the one who generates digital certificates. He sends, the certificate authority has its own public key and private key, similar to the server. Here, the server goes to the certificate authority and sends server's public key to the certificate authority. The certificate authority verifies the public key sent by the server, and with the help of its private key, with the help of the certificate authority's private key, the public key of the server is being encrypted and it is sent to the client side. We need to know what are the things which are present in the certificate generated by the certificate authority. Let's see now. There are three parts. Okay, issued to and issued from. So the from place has the certificate authority's name, who provided the certificate. So for example, here we'll take DigiCert. DigiCert is one of the certificate authorities, and the certificate is provided to Facebook, for example. So here in the issued to part, Facebook is present. Okay, and here the server's actual public key, which has not been touched, which is raw, the server's actual public key is present. Server's public key. Okay, and here again the server's public key is present, and one more thing is present. Which one? The private key of the certificate authority. The private key of the certificate authority is used to encrypt the server's public key, and the encrypted server public key, encrypted server public key is generated. Okay, so it has various other text info in it. The text info are present in it, and there are other info present in the certificate. This certificate is sent to the client from the server. See, the certificate authority generates this certificate, and this generated certificate is sent back to the server, and the server sends the certificate to client side. So the client opens the certificate and reads the certificate, the information present in the certificate. The first place the client reads is this part, issued from the DigiCert. It goes to the DigiCert and asks for its public key. Okay, since we follow asymmetric encryption and decryption, um, when we are using private key to encrypt, here we are using private key to encrypt, then we can only use public key of the certificate authority to decrypt. So the client goes to the certificate authority, asks the public key of the certificate authority. With the help of the public key of the certificate authority, it decrypts this encrypted server public key. Okay, so with the help of this one public key, this is being decrypted, you get a decrypted one. So the entire thing focuses on safely transferring the server's public key to the client side. That is our main goal. The encryption is being done with the help of CA's private key, and after encrypting it, it is sent over the network to the client side. Though it is accessible to the hacker, it is safe. Okay, he cannot access the digital certificate. It means the CA has actually signed the certificate with the help of its private key. Okay, so once it reaches the client side, it goes to the CA and asks for its public key, and with the help of the public key, it is being decrypted, and the decrypted one is available now. So on both the sides, the key is present, the server's public key is present, so safe communication can take place, and the entire thing is safe. This one is called SSL defines how the entire thing actually works. Okay, to ensure that the certificate authority is the right one or the safe one, we have intermediate certificate authorities. Okay, and the same process repeats. So this is how a safe communication happens between the client and the server. Okay, one thing, we'll have to validate this. How will you understand, how will you know that the decrypted server's public key is the actual server public key? So to validate the server's actual public key is equal to the decrypted public key, then we can tell the right one has reached the client. So how the decryption is done? Decryption is done with the help of public key of the certificate authority. How the encryption is done? Encryption is done with the help of private key sent by the certificate authority. This is how the TLS or SSL communication actually works. I hope you understood. Thank you.